Hi guys, in this video I'm going to talk about various sleep modes which help you to preserve energy on embedded device. Sleep modes are form of deep sleeping where you turn off special sections of your device, whether it's a CPU or peripherals and so on. So in a specific case in photon particle we have three various types of sleep. One is the sleep mode, the other one is deep mode, and the third one is the stop mode. And this table shows the differences between all three of them. First, in the sleep mode, you can actually see that CPU is running, peripherals are running, interrupts are running, memory, and the application is actually running. When I say app, I mean the firmware of your board, but the Wi-Fi is turned off and the current consumption is around 30 to 38 milliamps. Basically, if you consider this as just turned off Wi-Fi, nothing special. By the way, this is information from the official documentation of the photon particle. The second mode is called deep sleep, and deep sleep mode is very common in various embedded devices, from Arduino to ESP32 or similar devices. They all have some sort of deep sleep modes. And the third mode, so the deep sleep mode actually turns off everything. And you can see that the energy consumption is in the microamps, which is way lower than just turning off the Wi-Fi here. And the stop mode is kind of hybrid mode specific to photon particle, where CPU peripherals are turned off, interrupt is on. It means that you can register an interrupt, and the memory is preserved and the application is running, meaning that you can simply pause the application execution and the Wi-Fi is turned off. Of course, the energy consumption is a bit higher than deep sleep, but also much lower than sleep mode. And in this demo, I'm going to show you how to use various types. On my board here, if you take a look, I have a simple button connected to a pin, and I have a monitor for energy consumption. You can see that now I'm using 0.45 amps. And let's head to Visual Studio Code and start programming. The first things first, let's create serial communication so we can monitor things on a serial monitor. I'm writing serial.begin 9600. It's actually default value. And here let's write serial.println. I will simulate some work here, saying, let's say, setup started, and after that let's have some delay of 3 seconds, meaning during these 3 seconds that CPU is kind of doing something, but it's only just delaying. Serial.println setup done or complete, makes more sense. Setup complete, and in the loop I will also simulate some work. Serial.println work started, and here let's have the same delay, let's say 3 seconds, and after that let's write serial.println work complete. And after the work is complete, let's put our device to sleep. So I'm gonna write serial.println off to sleep. And now let's try various sleep modes. The first one is system.sleep for 5. Now the unit here is number of seconds, so I'm gonna sleep for 5 seconds, and this is just this. Let me show you. It is this mode now, the sleep mode. Okay, sleep mode. So if you remember, I just told you it turns off the Wi-Fi. So let's check it out once I flash it. Cloud flash. Oh, maybe, yeah, okay, maybe I should put here end of loop just in case. Yeah, that would be useful. Serial.println, let's say end of loop. Okay, cloud flash. Let me just go to the safe mode. Cloud flash. So to show you what's happening here, let's start a serial monitor with here. Let me just put it more up. So you can see that work started, work complete, off to sleep, and so this everything happens instantly. So obviously nothing is paused, and the application is preserved. If you check on the energy consumption, you can see that it is 0.39 amps. It just means that the Wi-Fi is turned off. This loop, work started, work complete, off to sleep, end of loop, and again goes to work started. There is this delay of 3 seconds between, and that's it. Nothing is paused, nothing is preserved, except the Wi-Fi is turned off, which brings me a bit of headache because I need to flash again, so I need to go to the safe mode to flash it. And let's try the other mode. So this is the sleep mode. I will comment out this line. Let's try the middle one. It's this deep mode. Okay, to get into deep sleep mode, you would use system.sleep, and again the first parameter is a constant, sleep mode deep. There you go. And the second parameter is 5. Again, after 5 seconds I will wake the board. So this is deep sleep, the most energy conserving mode. And let's try it. Serial cloud flash. Yeah, it failed because my Wi-Fi is off now, so I need to get to the safe mode. Hold on. Getting to the safe mode. That's the problem with the first. It doesn't restore. And the reason why it doesn't restore is very, very due to my, I wouldn't say my mistake, but take a look here. So in this previous example, I have delay of 3 seconds, and after that I went to sleep. So I've been sleeping at this point at line 16 here. I've been starting to sleep for 5 seconds, and the loop finishes almost immediately and reaches here again a next cycle of the loop, and here is a delay of 3 seconds and gets back to this line. So it has passed 3 seconds of my 5 seconds, so I still have 2 seconds of sleeping, I mean turned off Wi-Fi, and unfortunately, I mean in this code, this sleep cycle restarts again from 5. So I never get Wi-Fi back on because I'm delaying here 3 and I'm restarting the counter again of 5. So to solve this, I would either use, for example, here much larger delay, let's say 30 seconds, and here small, or here smaller delay of for example, 1 second, and after 1 second it will restart the board. Again, not convenient for flashing because it will leave you a tiny window where you can jump in and flash your code over the air, which is not useful. That's why I went to the safe mode, so I can flash now normally, right? And the monitor is trying to reconnect, which is great. And you can see setup started, works started, and off to sleep. You can actually see the serial connection closed. It means that it shut down the serial connection. And check it out, the current consumption, wait for it to go to the sleep, you will see. Now it's running those 3 seconds and drops to 0. I didn't catch it, sorry, I was looking at the camera. So this is running, and let's check it out here. Goes to 0.32 amps once it is off. Also, yeah, kind of my display, my USB meter is somehow giving me larger values. It should probably drop to the level of microamps, because I think my laptop is providing some current, or someone is using the current, I don't know why. That's very weird. But it's lower. The current consumption is lower. So this is the deep sleep mode, and you can see from the log in the terminal, which is very important, is that once it goes to off to sleep, check it out, it goes back to the setup. It means that the board literally restarted itself from setup and then goes to the work. And this means also that this line is never executed. Check it out. So off to sleep, and then there is no end of loop. So this is how deep sleep works. It wakes up, restarts the board, and starts the main loop again. That is the most energy efficient sleep mode, so you can use it conveniently, but you need to be aware that you need to monitor the variables and make your software compatible with the sleeping, in case you need to store some values or something like that. And let's head to the last sleep mode. I will comment out this line, and I will probably go to the safe mode again, because the board restarts each 5 seconds, and that's not convenient in my case. And the last one is system.sleep, and now the first parameter is the pin number, and the mode is rising, and I will put here, let's say 10 seconds. You will see why. So this mode is, let me show you, this stop mode. Okay, it just pauses the execution. I will just comment this as a stop mode. So we have all 3 modes here. Let me just go to the safe mode so I can flash. Cloud flash. Now it's flashing, and you will see the monitor. Now I'm waiting 10 seconds, just to be aware. And the reason for that is, okay, so here I have off to sleep, work complete after 3 seconds, and of course peripherals are shut down. And once it reconnects, you will see that it resumes back where it stopped. Here we will see end of loop. There. End of loop. And again, another work, off to sleep. So it literally paused the execution at this line, while all the variables are also preserved, because the memory state is also preserved. And why I use 10 seconds here? What does it mean? It actually sleeps until there is a rising signal on a pin, in this case D2, and if this signal is not met, then it will wake up automatically after 10 seconds. I can simulate that. By the way, you can see the energy consumption. Let me see when it goes. Now it's in sleep. You can see that the current has dropped, which is fine. And I can wake it up from the sleep. Let me see. There. It's waking up and goes back to the normal current consumption. So you can wake up using any signal on a pin. In my case, I use the button, and if this condition is not met, it will automatically wake up, in my case, after 10 seconds. So these are all the sleep modes that we used. You should probably choose the one that fits your general purpose or whatever project you have. Personally, deep sleep is the most convenient. If you want to have a long running device, it's very good. And of course you can put larger numbers, not just 5 seconds, because you can put even hours or maybe days. So I hope you learned something, and see you in next video.